Today our topic is graphing y equals ax squared plus c. So our learning target is how can I graph simple quadratic functions. Vocabulary for us, a quadratic function is a non-linear, so it's not straight, function that can be written in standard form as y equals ax squared plus bx plus c, where a does not equal 0. Because if a equals 0, then this first term would go away, leaving us with a linear function. Quadratic graph. So every quadratic function has a U-shaped graph called a parabola. So you can see pictured below, this U-shaped graph right here, I'm drawing in green, is a parabola. So that's what we call that shape. Parent quadratic function. Our parent quadratic function is y equals x squared. It's the basic quadratic function that all other functions stem from. So right here, graphed in green, y equals x squared. That's pictured for us. So there are certain pieces about a quadratic function. Right here, this arrow is drawing to 0, 0, this point, which we call our vertex. And that is the lowest or highest point on a quadratic function. So vertex is the lowest or highest point. So in this case, our vertex is 0, 0. The other piece of a quadratic function is right here, and it's called our line of symmetry. The line of symmetry cuts the parabola in half and goes through the vertex. Make sure you write all of this down. We're just going to get straight into graphing. We want to graph the following functions and compare them to the parent function, y equals x squared, which I have graphed for you in red. So on your paper, it won't be in red, but on my screen it is in red. All right, so to graph, again, the first thing we do is make a table, y equals 3x squared. So we want our x values and our y values. We're going to start with -2, then -1, 0, 1, and 2. Those are going to be your x values that you're going to use. Then we just plug them into our function to solve for y. So y equals 3 times x squared. Just replacing the x with our values for now. All right, now we can evaluate exponents first by Pemdas. So -2 squared would be 4 times 3 would be 12. If you're not confident in your operations, please use a calculator. -1 squared would be -1 times -1, which is 1, times 3 would be 3. 0 squared is 0, times 3 would be 0. 1 squared is 1, times 3 would be 3. 2 squared is 4, times 3 would be 12. So now we just want to graph those points. We can't graph the first point or the last point because our graph does not go high enough. We're only going up to 8. So we'll just graph the middle 3 points. -1, 3 would be right there. 0, 0 would be right here. And 1, 3 would be right here. Connect those points to make that nice curve. All right. So now we want to compare it to the red graph. So if we look, it's narrower than the red graph. It's skinnier. It has the same vertex though. lowest point is 0, 0. And then it also opens up. So that's for our green graph. Now for our next one, y equals 1/4 x squared. Again, set up that table, x and y. Put in our x values into our function. So we have 1/4 x squared, so 1/4 times -2 squared, 1/4 times -1 squared, and so forth. All right, to show you how to use your calculator to evaluate these, we can put 1/4 in parentheses as 1 divided by 4. And then we can do -2 and squared. Press enter and it'll evaluate it for us. So we get 1 for our first answer. Then we can put -1 in for x. We get 0.25. When we put 0 in, we're going to get 0. And then we can put 1 into our function. And we get 0.25. And then we can put +2 into our function and get 1. So we have 1, 0.25, 0, 0.25, and 1. Now if you look at both of these, there's a nice symmetry in our y values. If you look, they start at 0, and then as you go up and down, the values are the same. So there is a nice symmetry because they make that parabola, that nice U shape. So let's graph our blue function. We have -2, 1, would be right here. -1.25 would be about here. 0, 0. 1.25 and 2, 1. So there we see that makes that nice U shape. So now we want to compare this to our red function. If we look, it is wider than the red function, but it still opens up and has the same vertex of 0, 0. All right, next example, we're graphing again. Graph the following functions and compare to y equals x squared. Again, I have that graph for us. Mine is in red. Yours will not be. I apologize. Have the first equation be our green equation, so we'll put x and y. Plug in your x values. Put them into our function. -2 squared is 4 times -2 will be -8. -1 squared is 1 times -2 is -2. 0 squared is 0 times -2 is 0. And then we have that nice symmetry piece. Graphing, this will only be able to graph the middle 3 based on our graph because we don't go up high enough. So -1, -2 would be right here. 0, 0 right there in the middle, and then 1, -2. So we connect those points. Now compare that to the red function. If we look, it is a little bit narrower. It has the same vertex of 0, 0. However, another difference would be that it now opens down. The reason for that is because this first term is negative. So it changed all of our answers to negative answers, which means we open down. Second example, we have y equals negative 1/2 x squared. Oh, but now we're adding this plus 2. So let's see how that kind of changes the graph. We have x and y. Again, plug in those values for x. We have negative 1/2 times negative 2 squared plus 2. Continue to plug in your x values into your function. We can use our calculator again to help us evaluate these. So we have negative 1/2 times negative 2 squared plus 2, which gives us 0. We have negative 1/2 times negative 1 squared plus 2 would equal 1.5. Negative 1/2 times 0 squared. Plus 2 equals 2. So we have 0, 1.5, 2, and then again we're going to have that nice symmetry in our values. So the symmetry starts at the x value for 0 and then follows suit. So now we want to graph our coordinate points. So we have negative 2, 0, should be right here. Negative 1, 1.5 should be right about here. And then 0, 2 right here. And then 1, 1.5, and 2, 0. So if we look, again, the parabola is opening down because of that negative first term. So if we're comparing it to the red graph, we have opens down. It's also wider than the red graph. And its vertex is different. It's not 0, 0, it's 0, 2. The reason for that is because we added 2, so it changed our vertex. In all of our other graphs, we didn't add anything, so we were really adding 0, which made for that 0, 0 vertex. So now just to summarize the different pieces of our simple quadratic function of y equals ax squared plus c. If a, drawing that arrow to a, is a whole number, it's going to be narrower than our parent function y equals x squared. If, however, it is a fraction, then it's going to be wider than our parent function, which is y equals x squared. If we have a positive a, again, we're still talking about a, then our parabola will open up. If, however, it is a negative a, then our parabola opens down. And then our c, that piece controls our vertex. So our vertex will be 0 and then whatever value is put in for c. Now remember, this is only for this simple quadratic function where it's just ax squared plus c. That's all the notes I have for you today. Please remember to take your 10.1 video notes quiz.